Welcome to Wireless Future. My name is Erik Larsson and I'm here as always with my colleague Emil Björnsson. Hello Emil, how are you this morning?
I'm great as usual, how are you?
Good, thank you. So this is episode 20 today, and this week we have as guest Liesbet van der Perre from KU Leuven. Liesbet is a professor at KU Leuven. She's an expert on wireless technology. She's also the scientific lead of the Horizon 2020 project Reindeer that's developing physical layer infrastructure for 6G physical layer. Radio Weaves is the name of that physical layer infrastructure, and it's built upon using distributed MIMO arrays to serve many terminals simultaneously, all below 6 gigahertz frequency. Liesbet is also an expert on Internet of Things technology, and that will be the topic of our conversation with her today. So, hello Liesbet, great to have you with us on the podcast.
Oh, hello, good morning. I hope you are all doing fine.
We are. So, how are things in Leuven?
Well, things are pretty good here, and going back to lectures and enjoying having students in front of me again for the lectures. So, yeah, that's quite energizing and motivating, and definitely fun to be back in real life on campus.
It is indeed the same for us here, I think.
Yeah.
So the conversation today is going to center around Internet of Things, and I thought that perhaps we could start by finding some common grounds on the terminology. So what is really Internet of Things? Is there like a definition or a way that we should think of what makes a technology really being Internet of Things?
Well, I'd like to see it as an architecture in a sense, where we have three elements in there. We have the things, which could be all kind of objects that get some smart tags or smart devices with them. These are the things that become then connected to the internet. And then you could say, well, on one side you have the object, the things, on the other side you have the internet, and they get connected to wireless communication. So you could say it's wirelessly connected objects with embedded typically sensors or actuators or whatever in there. So very often the Internet of Things is a kind of remote sensing activity, I would say, where wireless communication, of course, plays the connecting role in there.
I see. So if you have a device at home, like a meter of some kind or a camera that is connected with a cable to the internet, like a conventional internet cable, does that count as IoT as well, or?
In my opinion, it does count, because it has a connection to the internet and it's an object which then typically has sensors. A camera is a sensor. I would say it does count. Of course, more recently we see the evolution where many things get connected remotely with no wires attached, and then it is what very often is considered as IoT devices or things that need to be low power with wireless connectivity. But in a broad sense, you could say, yes, we already have a lot of things connected to the internet, and so it's just extending, I would say, with energy-constrained devices that ideally have no wires at all.
I see. So I've seen many times these kind of graphs about that, the number of maybe human-operated devices starts to still increase, but converge maybe in terms of how quickly it increases, because there are just so many devices we can have in our pockets and our hands, but then that the IoT devices will be increasing very rapidly and soon outnumber the number of human-driven devices. Have you already come to that point where there are more devices that are IoT than human devices, or is this something still that happens in the future?
I would say, I think it depends on how you count. If you would count all the Bluetooth devices, but of course you could say the Bluetooth devices are also connected to people very often, but if you would count all the Bluetooth devices, separate devices, probably we are there. But if we look at remote devices, I don't think we're there today. I think there is actually quite some technical challenges to be resolved. There's a lot of trials currently, a lot of pioneering experiments that demonstrate that the functionality can be great, but that the technology still is not ready, I think, for the large-scale deployment.
So what you're saying is we're going to see in the future increasingly more and more of these devices connected to the internet and then providing various kinds of services. But what are the opportunities here that this technology will offer us eventually? I mean, will it be mainly for like factory automation with sensors that are everywhere, maybe sensing, like let's say physical quantities in a factory or perhaps environment? Or will it be mainly in the homes of people or outdoors? Or what are the? I mean, this is a term killer application, right? So. What are the main emerging applications that you think we'll see of Internet of Things in, let's say, 10 years down the road?
Well, I think as we have seen with wireless communication, it broke out mostly in Scandinavia, where it was very often not that easy, or remote areas where it was not that easy to have wired networks. I think the biggest value comes from the places where it's very difficult to get the wired networks. And for example, we've been involved in the program, Horizon 2020 program, IoT for food and farm, the IOF 2020 program. They had about 30 different use cases all rolled out in internet for food and farm. And there you could say it's about precision farming. It's also about food safety. If you bring feed to animals, that you can make sure that what is delivered is correct and so on, that doesn't have the wrong medicine. It was amazing to see. It's tracking and tracing cattle. So everything where normally you need to travel long distances and you can replace that, I think that are the most interesting. The same, of course, in factories will hold if you have a lot of moving things, where the same as for wireless communication, it's more difficult to have the wired connected to the networks. So if you have much more robots and cobots and whatever, and those have sensors on board, I think that also is going to be a killer application. I would say anything where today a wire is a difficult story. Think about smart meters in homes, where today, if you can make them wireless connected, and going all the way to the place where they want to follow up how much you're consuming in electricity and water and so on. So I think everything where a wire or a distance is a hurdle, as we saw it with wireless communication, for me could be a killer app for IoT.
Right, so which means I presume mainly outdoors then, right? I mean, at least it'd be a lot more difficult to install wired infrastructure if you think of an application like precision farming or something like that. And we're talking about huge areas of land, right, that would need to be supported by this connectivity. And obviously that'd be wireless would come to rescue there. So speaking of precision farming, because I found that to be a somewhat fascinating application. What is the vision there? I mean, is it like every cucumber would be equipped by a small sensor and a Wi-Fi module, or is it more like you'd have drones flying over the field to check like how the crops are doing, or where would the sensors mainly be deployed, and what sort of data would they be gathering there?
Well, I think one of the things that is gathering is the soil information to start from. For example, there could be very heavy rain here where I am and not 20 kilometers further down. So maybe there is no need for watering plants where I am, but there could be 20 kilometers further, or the other way around. When all the crops have been harvesting and it's raining a lot, it seems that then a lot of chemicals are coming off of the fields, and then you could biologically recuperate them if you know when it's happening. So I think soil monitoring is one of them. And also cattle monitoring can be quite interesting or important. And there, of course, not every cucumber, but you can imagine that every cow could be monitored to see if a cow is not moving a lot anymore, the cow may be ill. So I think that's the kind of level where it becomes very interesting. But also the machines, it turns out that if you could follow up machines and follow up from a distance when they need to come in for service, you could reduce a lot of cost and waste if you avoid that the machines stay out for too long and maybe have a problem and don't come in for service timely. So it's a lot of these things. I would say not on the cucumber level, but I do believe that maybe on the cow level it could work.
Right, interesting. So monitoring soil quality and checking like moisture and nutrition and contents and presence of other chemicals perhaps, and then even cattle. I mean, so every like pig and cow could have a small sensor and a Wi-Fi tag on board that provides a data stream continuously about their health and about where they are like going and what they had for a meal and so forth.
Yeah,
it's quite fascinating, I think, as a prospect for future farming.
I think the only thing you mentioned is the Wi-Fi tag, but we'll get back to that later on.
Sure.
Yeah, I think if I look around myself here, I gave a lecture about Bluetooth last year, and then I tried to also look around what kind of devices can I have just to show off the kind of diversity of different things. And just in smart home kind of automation, you can have smart light bulbs. I have that. You can have an AirTag, whatever you call the technology, for finding your keys that you have misplaced somewhere in your home. And there are a number of different things that can improve your life quality in your home as well, I suppose. So one thing that I try to get my head around, since we call this podcast Wireless Future, is why do we make these things always wireless? Why do we prefer that? I understand that you don't want to put a wire on a cow, but if you have like a camera or you have some kind of device that is at a fixed location, do we want to connect those with the cable, or is there still reasons to make it wireless even if the device will never move?
There are, for convenience reasons, definitely there are reasons to make it wireless. For example, in the city of Leuven, they're now doing a monitoring campaign of noise disturbance and noise pollution, definitely at night. And the people installing the devices say it's really problematic if you need the mains power for all of these sensors, because they want to follow in a street what is happening with the noise on a very high precision. And they say if we need the mains power, it's just very expensive just to get them installed. If we could do something as simple as just putting them there, no wires at all, it's going to be so much more convenient to do it. Except, of course, as you already mentioned, the mobile things, you have no choice. But for the convenience, for large rollouts, it's going to be much easier. We are going to start a campaign measuring trees. Actually, we are already measuring trees. Also, people don't like to see electronics coming in and wires coming in everywhere. And even the aesthetic part, and I know, Erik, we have talked about this in the past as well, the aesthetic part is also something important. You don't want to have the wires coming in everywhere. You don't want to have the wires going to all the trees you want to monitor. If you can put the monitor in a birdhouse, it's what we intend to do, and put a sensor in the birdhouse, and you just put a birdhouse there, no wires attached, then people will rather like the technology than say, this is actually disturbing me in many ways. And it's much more convenient in installation and also in dismantling afterwards. We need to think ahead in sustainability. How do we get the things back? So if the wires have not been installed, it can be easy to also get back the devices afterwards.
Yeah, it's a neat vision with a birdhouse. So, I mean, you're mentioning, I think, here some significant technical challenges, right? If there isn't a power cable to power the device, then where would it get its energy from? Would there be a battery, or would it harvest power from the environment in some way? Or what's the vision there, and what are the main technical challenges in that regard that you see?
Yeah, I think energy is definitely one of the main, if not the main challenge today to IoT, and definitely remote IoT. So batteries are inevitable almost, I would say. Even if you want to have energy harvesting, I think you still need a way to either have a supercap or a battery to temporarily store energy. And these batteries, by the way, are often very bad in chemicals as well. So in order to avoid a lot of batteries and recharging or having to go back to the places, of course, energy harvesting in the field is the most promising thing to do. And you could say there's two things. Either you take things like solar panels, and I think definitely solar panels have the biggest, if you have some sun, of course, and some light, this has the biggest return. Doing things with wireless connections still is very difficult, I would say. Not a lot of power can be transferred. It could be good for waking up devices, but for real energy provisioning of sensor systems, I'm not sure it will ever be good enough. And unfortunately, you have places where there is no sun. Even if you design your device, which should be possible to go a whole year, even in places where the sun is not shining for a couple of months. In outdoors, you can say we could design things for working at least a whole year with a small solar panel. But in basements where you do a smart metering of water meters, you don't have them. So there, unfortunately, currently the only solution is to go with batteries, I think.
So you're saying essentially here that IoT devices would have batteries one way or the other, but they could also have onboard energy harvesting technology that helps recharge the battery. And among the energy harvesting technologies, you mentioned solar cells in particular, which is of course a great technology, but it only works when the sun is shining, right? Or at least there is some light. I mean, even like a place like Sweden in the winter, we've got like 5 hours, best case, of sunlight in December. So the rest of the time, then you'd have to rely on stored energy. But are there also other technologies that you think will become commonplace here, like harvesting energy from vibrations, for example, or if you put this in the smart farming application that you talked about earlier? I mean, you could think of like putting the sensor on the cow and maybe even extracting, I don't know, something from the movement of the legs of the cow, or even the body heat or something, or so what are the other available technologies, say, for energy harvesting? I mean, there's obviously RF as well, right? But then you have to be rather close if you're going to rely on harvesting RF power. But could you say something more about that? Like, in addition to solar cells, how could energy be harvested from the environment?
Yeah, I think talking about machines, then vibrations can do it. We have the systems that are the tire pressure monitoring systems. They work based on the vibrations. Of course, they're in a tire, plenty of vibrations there. And it's been looked at whether, for example, indeed, the cow could harvest from the walking. The thermal thing is a very difficult thing. People tried it in the past, and that is very difficult. But if you're sure things will move, there could be some, but it's a very small harvesting capabilities. For small actions, it could work. But another thing that one of our PhD students is investigating is to check whether we cannot recharge based on drones. So already today, if you have a lot of data, you can use drones to go collecting data. But if you do that, why not charge the drone? And you can imagine the drone could be in a sunny place or could be in a place where it can find energy, and bring the charge, collect the data and bring charge, and with just wireless transfer, nearby transfer, with just the way we do it today with all kind of devices, or at contactless. That works amazingly well. You can get very high efficiency compared to RF based. And it's a neat thing to do. It's a topic we have as a PhD student, and it's a neat thing to do. You can bring the charge with a small drone, and the drone could either harvest itself or find energy when it's available, collect the data, and bring the charge. And
then transfer power and charge through inductive coupling.
Yeah, inductive. There is people that also look even at other ways, for example, infrared-based or could be as well capacitive, but inductive at this moment is the most straightforward thing to do.
Right, yeah. So harvesting either from the sun or from vibrations. I mean, thermal obviously is very difficult unless you have a huge temperature difference, right? So I suppose the body heat of a cow is not going to be enough here. Or having drones flying around and like conveying the power through wireless inductive coupling, which of course means that the drone has to be very close, right? Or even land on the thing. But that's quite an interesting prospect, I think.
I have a student who spent some time looking at some of these IoT sensors that existed. Just we wanted to quantify for how long you can use them on a standard batteries, and I think one of the things we realized that maybe if it's just going to make like a temperature measurement a few times per hour, then that energy consumption from that is not much. So our conclusion was rather that the main thing is going to be the wireless link, particularly if you want to have transmission over long distances. So that leads us over more to what about the wireless connectivity? What kind of interfaces should we use? Can IoT devices use Wi-Fi or cellular standards in the same way as our mobile phones, or do we need something different?
Yeah, maybe I can comment. We came to the obvious same conclusion that power-wise, the biggest problem is the wireless. We did some calculation as well. And one of the things we need to be very careful for, I think, is also the sleep power. Because if you sleep most of the time, you should sleep very quietly. So I think in energy, if you do the rest of your job good, all of a sudden the sleep energy might become dominant. So but in power, definitely the wireless is the most dominant thing. And there, one thing to do before even transmitting anything is that we say we should think before we talk. It's always a good idea, but also in these kind of devices. If you're measuring temperature, like indeed, as you say, a couple of times a day, first of all, make sure that you don't send it if it's not needed to send it immediately, but that you collect some data and that you can do much better in energy per bit if you collect some data together and you assemble some data. So I think that's one advice we have. Sleep as quiet and as much as possible. Think before you talk. And then in talking, there the problem is that a long distance, that doesn't go well, of course, with low power. If you look at mobile phones, we receive more than we transmit, but in IoT, the opposite is true. So yeah, it's a problem using all the air interfaces that we have developed for mobile phones, like for 4G, like for Wi-Fi and so on, for IoT devices, because they don't fit the application very well, they don't fit the energy budget at all. So new technologies are on the way, I would say. Low power wide area network technologies, of course new generations of Bluetooth for the shorter range work very well. Bluetooth LE is fantastic, definitely if you need a considerable amount of data. But for longer ranges, new technologies are really needed. The low power wide area networks, I think, are vital to make these things have an autonomy which is reasonable.
Yeah, so I have seen a few different names of standards or a version of standards that already exist. I guess my light bulbs up here are using Zigbee. And then I heard about LoRa and Sigfox as being some standalone kind of systems for IoT devices. And then there seems to be narrowband IoT, which I suppose is a part of 4G and maybe 5G, uses the same kind of names. So what is are these like competing technologies for the same use case, or are they meant for different kind of ranges or use cases?
Well, I think the first one you mentioned, Zigbee, Bluetooth, I think these are meant for other use cases. For use cases, we talk about few meters to a few tens of meters. So Zigbee can go a few tens of meters. Bluetooth can only go a few meters. So I think there's really different use cases. But if you look at use cases that need several tens of meters, hundreds of meters, kilometers, tens of kilometers, then I think we're looking at indeed things that you have mentioned, Sigfox, LoRa, and narrowband IoT. They are a little bit fighting, I would say, for the same use cases. They all claim the same use cases that we've been talking about, like precision farming and those kind of things. But I don't think they should be competing, because I think they're actually quite different. LoRa and Sigfox both are really low power for the devices, but very restricted in data rate, and almost no downlink. So narrowband IoT, on the other hand, is less restricted and has more downlink. But for very simple applications, the power consumption will be much higher, and so also potentially the energy. So why are they not competing? Because I think, you could even do best in combining a multi-rad, where you combine a LoRa or Sigfox thing with a narrowband IoT, and you could use for most of the time the LoRa probably, and only when it's needed you go to the narrowband IoT, for example, for a software over-the-air update, or if all of a sudden you need more data. Then we have shown that in energy per bit, narrowband IoT even becomes better than LoRa, although in power it is never, but in energy per bit, and that's in the end what counts, the total energy counts for the battery. For some situations, narrowband IoT becomes more interesting. So yes, on the surface they are fighting, but in practice I think there is a lot to gain in combining the technologies.
So it sounds like there is no single technology that's best for every use case here, right? I mean, Zigbee and Bluetooth are for a range of a couple of meters, and Wi-Fi slightly more, and then narrowband IoT, well, goes up to the cellular coverage, and LoRa and Sigfox could go even further, right? Although of course the data rates are very limited. So this multi-rad concept is quite interesting, I think, where the sensor is able to then switch adaptively between different standards depending on how much power it has at disposal and depending on its specific needs at the time. Is that something which is deployed and built already, or is it rather under development? And when do you think that we'll see IoT devices with this multi-rat capability deployed on a wider scale?
Well, I must say it's not deployed to the best of my knowledge. It's been notified by several researchers that this should be further investigated. Unfortunately, many vendors are very big supporters for one or the other, and they try to push their technology everywhere. Like, for example, indeed, with narrowband IoT, you have the cellular coverage, you have the license band, you can have some quality of service guarantees. And if you need, for example, a short reaction time, you will need that. So many narrowband IoT vendors, they will say, you need narrowband IoT because you will be in trouble sooner or later. You have an alarm situation, and then you need it. But I think, well, it's the wrong thinking. So we don't see it today. And I think we'll need a lot of convincing arguments, and maybe people will see that, energy, if you always use narrowband IoT, the autonomy of devices is way too short. So you should find solutions for getting really the true IoT explosion that has been predicted. And I think multi-rat could help in there.
Interesting, yeah. So if we take a closer look at the, say, physical layer and MAC layer techniques that IoT devices will use, then what are the main challenges there, and what technologies do you see emerging? I'm thinking in particular, I'm thinking of initial access. For example, I mean, at some point these devices have to join the network, right? And there might be a very limited downlink, perhaps. And they have very limited power, as we already discussed, and they have to make themselves known to the network and even get a slot to transmit. I mean, so how is this expected to work?
Yeah, this is definitely one of the points. So there are protocols today, and it's one of the problems why narrowband IoT is using so much energy. It takes a lot of power just to get connected to the network. I think in general, what we should do is the network should be listening very well. And then the devices can be much more silent in transmitting. And it's listening very well to devices that could be there and, if needed, detect collisions and resolve it all at the infrastructure side where we have processing power. I think that is the way forward. And if we say listening very well, we also, of course, think about large antenna systems. That if you have a large antenna system, at the network side, at the infrastructure side, then the power transmitted by devices could go down a lot. And the main problem with these large antenna systems, again, is the initial access, I would say. You need to know, if you want to be directively listening, you need to know where the devices are, and you need new solutions for the initial access to first know where the devices are. Now, the good news...
Yeah, definitely...
Yeah, there is some good news. Yeah, that, as you have said before, is many of the devices are rather stable, and the channel response by that also seems to be quite stable, and only having few possible states where most of the times devices you see that get back to very similar channels, and that is what we try to exploit in here. So the fact that once you know where they are, you can be quite sure you'll find them in the same direction, so to say.
Mm-hmm. Yeah, I mean, definitely large antenna systems, massive MIMO and distributed MIMO and radio weaves technology and so forth will come to rescue here, right? Because number one, you get the array gain, and number two, you also, with a large array, have enough spatial degrees of freedom to even resolve collisions on the random access channel. So I concur entirely here. There are great opportunities, I think, to develop multi-antenna technology to be able to listen and detect very weak signals from these IoT devices that might be very far away and have very limited power budget on their uplink. Yeah.
So I came to think about in addition to the IoT name, there is this name machine type communication that has been used within maybe 4G and 5G discussions. And I think sometimes they talk about massive MTC, like machine type communications, sometimes critical MTC. Is this also different kinds of IoT, or I'm just trying to get the terminology straight here for the listeners?
Yes, for me it's also IoT. I think when we mention IoT, we also look at the devices and so on. I think if we mention MTC, machine type communication, we focus specifically on the wireless part of it, while IoT technology is broader. Some people, some of my computer science colleagues will only talk about platforms and databases and whatever when they talk about IoT. So the IoT technology, I would say, is the three parts. It's the things, the connectivity, and the side of the cloud or whatever dashboard. MTC specifically focuses on the communication, the wireless communication between the things and the network. And as you mentioned, it's good that it's mentioned that there is different kind of applications. The massive typically is for what we call the, what I've been mentioning in precision farm, things that are not time critical, that if you miss a packet is probably not a problem and so on. But the critical applications, they need a different quality of service levels, and often they need a very fast reaction time. So other technologies will be needed, although also there I think large array system can help a lot. But other protocols definitely will be needed for these critical systems that need a very short response time and high reliability.
Indeed. So I think we are back at this kind of problem that I think we talked about in previous episodes as well, that if you need to be very reliable, if you need to be very energy efficient, then you would like to transmit a lot of data, but that is not what you want to do in these cases either. So there is always a kind of trade-off between energy efficiency and reliability and things like that. So what I was also thinking about is, where do we really stand here on an implementation level? Because obviously there are certain IoT products that one can already buy, but then there are also some of the things I believe that we talked about that are more futuristic. So could you say something about what we can do today and what we are hoping to do tomorrow or 10 years down the line, so we can get a sense of where the research is heading?
I think what can be done today is there are narrowband IoT networks deployed worldwide. There are LoRa networks in large of parts of the world, so we can connect to the networks. I think that's an important thing to start from. The networks are there, so you can start connecting things to the network, and people are doing it. Today, I think if you do a good design, you do your best to have devices there for 6 months or for a year, and very often we say if you can do a full year of monitoring, that's already interesting. But of course, we want to come to the situation where you want the devices to be there for 10 years or for 15 years and still do more than a measurement once a month and having big batteries that don't lose their energy. So I think in order to have prolonged autonomy and go beyond what is, I think, still a trial phase in a lot of situations, but to continuous monitoring and really install base and roll out systems that are there to stay for longer term, there is this way to go. And some people will say, we can make devices that can stay around for 15 years, but it's then really not doing much more than one measurement every day, for example, simple measurement. If we want to do more measurements, for example, we want to do wildlife detection, see how heat stress in cities, for example, is affecting trees, or how drought periods are affecting bats, and you can listen to the bats with ultrasonic systems and so on. That asks for much more data capturing, and there the energy solutions today, I think, are not sufficient. So I think we need to come up with solutions that do more thinking also on the edge in the devices, deep nested intelligence and low cost, low precision processing to get enormous amount of data that you can get from monitoring down to essential indicators that you transmit, and avoid that you transmit all the data, but have much more edge intelligence and low cost, low power processing to have richer applications for a longer time than what we have today, I think.
So it seems to me, I mean, that the applications are so diverse here, right, that some sensors might have a single information bit to send once per hour or once per day or something, and some other devices might participate in the training of some advanced machine learning models in the cloud and have to send hundreds of thousands or millions of bits every second or every, I don't know, minute at least, right? So the discrepancy or the difference in required data rates are many orders of magnitude here, depending on the application that we are discussing. which also calls for entirely different technical solutions, I think. So one thing that I know a lot of folks are concerned about is security. So now, speaking of these extremely low power and low cost devices for IoT, what would they be capable of there in terms of authentication, for example, and what sort of cryptography would they be able to do here? Because it appears to me that, I mean, this is all now, communication is all over the air interface, right? So it's a broadcast channel, so anyone can spoof or jam the system or pretend to be someone else or just, well, jam the whole thing for that matter. But speaking specifically of security in the sense of authentication and the integrity of the data, how much of cryptography would these devices be able to actually do?
Yeah, I think it's important to be aware of it. I think indeed cryptography is important, and many of these devices today, fortunately, can even do the AED standard thanks to the fact that processing power has become. So I don't think you should do it on a processor. You really need a hardware accelerator, and we've shown to students that it makes all the difference. So if you have a good hardware accelerator, but in the same time, there is new standards that will come for specifically IoT devices. So new cryptographic standards, a new competition is around, like AED was a result of a competition, is around for security for IoT. Definitely we could bring you in contact with people that specifically work on that. Lots of work is going on because indeed we need new classes, I think, of cryptographic algorithms better fit for these devices that are having much more constrained energy.
Mm-hmm. But still you're suggesting, I mean, that even in the most power constrained scenarios, there would be enough computational power on board of the device to implement at least some level of cryptographic security, which sounds like a reassuring thing, I believe. I mean, in the world of cyber attacks and so forth everywhere, right? Yeah. That's good to know, indeed.
I think, unfortunately, as wireless communication specialists, we don't like to say it, but the wireless is dominating in the power and the energy. So, the others are doing a good job.
Indeed.
So I was thinking about sort of the energy efficiency or sustainability aspects of this, because we always have this kind of trade-off, I think, when we are developing new technologies, that on the one hand we are designing something that makes maybe our lives more convenient or make sure that a company can produce more goods using the same amount of money. But then it also sort of leads to that we increase our energy consumption, we increase our resource utilization in the process, so that we actually are just more efficient, but we are still using more of Earth's resources in a faster and faster pace. Then it seems that we also have the hope that new technology, digitalization and things like that, like IoT is really a big example for, will make our society more intelligent, and therefore it can lead to sort of a more energy efficient and sustainable future. What is your take on this long question? Is it do you think this will lead to a more energy efficient future, or just a more convenient life for us?
I'm personally hoping, and I think it should be our mission, to help making things more energy efficient. Just think about the number of traffic jams that could be avoided, or just visits to places that can be avoided if you can just transmit data wirelessly. Clearly that should be much more energy efficient. And if you can detect, for example, a leak of water in an early phase thanks to IoT, you could save a lot of water. If you see that it seems about 30% of traffic in cities sometimes is just spent in finding parking places. So if you know that if parking places are connected to IoT devices, we could save a lot of energy there as well. So I think IoT can help a lot in making other services more sustainable, but we should be very careful and not repeat the problem we have generated with the solar cells. I think in the solar cells we said, of course we need solar cells. We put them on our roofs. We have not thought about what will happen when they are end of life. And I think we should now already think about IoT technology and their end of life. I think we learned more now. We know that we need to design circular products. And IoT, I think, should there be an example and maybe a solution for a lot of problems we have in implementing the circular economy. Because they can talk, they can tell us, okay, I'm end of life. So we should design them with self-diagnostics. Not only my battery is flat, but more than that, with self-diagnostics, indicating this is my position, and now I know that I'm not functional anymore, or have not been functioning for some time, so that they can be recuperated. We should design them, I think, to be modular, so that, for example, we use biodegradable solar cells. That's already possible today. And maybe we don't need to recuperate the solar cells. Maybe we can try to build as much as possible of the electronics with biodegradable things. It's not possible for the batteries. Maybe we should make sure that the batteries could also be recuperated by a drone, and that we get a notice in the network like, this device is not functioning anymore, go and recuperate the battery. Because imagine millions of batteries everywhere just leaking chemicals of IoT devices that have finished their mission and that are never recuperated. And now I'm going to get enthusiastic because I'm quite chilled by the idea that suppose we can do that for IoT devices. And then we could start putting IoT devices in a lot of other things just as kind of canaries to notify this thing is not working anymore, it's this thing, come and pick it up or do something with it. To help all the great ideas on circular economy in practice by saying, well, let's put IoT devices in many of these things, and then we will know, for example, we know in Belgium that there's plenty of old fridges, maybe not used anymore, but nobody knows where they are. So where are all these appliances that are not functioning anymore? And e-waste is one of the main problems. For example, in Belgium, we only have 2 of the Sustainable Development Goals where we score red, and where we say we need urgent action, and one of them is waste, and IoT or e-waste is an important element in that. I think also on European level it becomes more and more clear that e-waste is a problem. So instead of creating more e-waste and leaking batteries in the fields with IoT, can IoT not be a solution for finding out where is the e-waste and recuperating it timely?
I think you're really touching upon the question I'm sitting on here. I mean, so we spoke a lot about the energy, right? And that's one thing, but e-waste might be at least as an important problem, because if you think about it again, I mean, if every cucumber has a soil sensor next to it, then there's just no way that we can trust all these sensors when they reach the end of their lifespan will be properly recycled and so forth. And so to what extent is it possible to build electronics that's completely biodegradable? I mean, in the sense that, like, for example, you eat half an apple and then you throw it like somewhere, it just rots, right, and becomes like soil, and it's just part of the like natural cycle in nature. But if you put a soil sensor there, it would contain, I suppose, at least some small amounts of toxic elements like heavy metals and batteries and so forth. Where does the technology really stand there? Do we know that in terms of like building electronics that could do all these things, like communicate wirelessly, harvest power perhaps, apply cryptographic mechanisms to ensure authentication and all that, but at the same time be biodegradable? Is that even possible? I mean, is it a vision that technology could realize, or is it not? What do you think?
Well, I think we're definitely not there yet, and I'm not sure we will ever be. But for biodegradable solar cells, for example, if people would have said us many years ago that they would reach an 80% efficiency, we would not have believed it, and today that's the case. So I think for energy harvesting, there is a possibility today to go that direction. It's going to cost some more area, but maybe sometimes that's not a problem. For many of the other functions, while it's been a research domain for several decades, I don't think we're close to doing the things we need to do. Yeah, you can make it for RFID tags probably, but not for the things we need to do. So we'll need to think about smart combinations, I think, of making some things biodegradable, and for the others, avoiding the most toxic elements and making sure that the most toxic elements at least are recuperated. And the interesting things with wireless devices, of course, is that we can communicate with them and they can let us know, in theory at least, they could let us know, like, We talked a lot about initial access protocols. I'd like to start up a new project that is about the opposite and final access protocols, where you say maybe at a certain moment you say this is the final message I will send you. You have these kind of flares that you send, and where we would need channels that listen continuously to these flares for devices saying this is my last message I will ever send. Here I am, and please recuperate me. So that's a different story than the initial access. So this is a final access, or I don't know how we should call it. We have had these wake-up radios. Maybe we should also have sleep-down radios, radios that notify, I'm going to sleep, I'm not going to wake up anymore.
That's really exciting, I think. I mean, having like the device sending a message that, look, I'm out of battery, this is the last thing you'll hear from me, please come and pick me up and recycle me, or something like that. Fascinating prospect, I think.
Yeah, I must say, I'm glad to talk to both of you, because I've been thinking about it, but I haven't found any good technical solution. I've been talking with some colleagues on it, and it's not straightforward, because if we could do it, it could not only be a solution for the IoT, but it could be a solution that we put in so many other things. If we can make it done, it's like we can listen to faraway stars. We can see faraway stars bringing messages. Could we build an infrastructure, and should we have an infrastructure, or should it be peer sensing or whatever, to pick up these last messages? So any ideas? Maybe we should have a discussion, a brainstorm one day on how we can solve this problem.
Absolutely.
So I think you have mentioned several good future research areas here in your answers. So I was thinking more to wrap up. Do you have some general recommendation for people who gets excited about this topic and would like to learn about it and start doing research? What should you learn? What do you need to do to get up to speed on what is the state of the art, and what do you see as the main challenges that you would encourage students to tackle first?
I think for students, although they don't like it too much, the first thing I say, you need to look at applications, because it's really about enabling applications. The technology is not necessarily that difficult, but indeed there is no one-fit-all solution. So the first thing to do if you want to build something is really think about an application. There's so many different. You can be creative. It's fun to do, but you need to first have a very good understanding of everything your application requires. Not only what is the distance, and what is the data rate, but how should I install it? We did a project where we installed IoT devices on chip. They didn't think we were going to do it. They thought it was just hypothetical. And then I had the bus coming, and I said the bus will be there that day to pick us up to go to the sheep. And I said, but how are we going to connect it to the sheep, and so on. And it should be waterproof. And so think about the whole application first, and then find the technologies that suit your application. I think that is the way forward. Application-oriented research is very important here to make the breakthrough. And next to that, think about the whole cycle. Think about the sustainability and the autonomy, and make it a philosophy to save every little picojoule of energy you can, I would say.
Yeah, it's great to hear all this. I mean, so IoT is really such an interdisciplinary topic, right? It will require developments in, communications theory, say for one part, but also electronics and new applications. And also these applications are so diverse and set so different requirements on the system, both in terms of like the data rates that we need and the range and the connectivity and all that, and also in terms of whether these devices have to be biodegradable, or whether we could connect them with a cable and just collect them together when they are like not modern anymore. So I think with this we'll approaching the wrap up here. So thank you, Liesbet, very much for having this conversation with us. It's been very inspiring and educational. And thank you, Emil. If you want to say something or have any final comment or question, any of you, before we close up?
No, I think Internet of Things is really this big term that is capturing a lot of things that's going on in society, just as big data and many other of these big terms. And I hope that we have provided you, thanks to Liesbet, a good breakdown into some of the important parts and components of this concept. So thank you very much for being here.
Well, thank you for having me as a guest. It's been a pleasure talking to you, and I hope we can progress on this technology with many people around the world collaborating. That would be great.
Sounds great. So with that, thank you everyone again, and thank you to the audience, and see you next time. Bye-bye.
Thank you.